Do 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 do. Do 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 do. Do 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 do. Looks like we got some new PLA in red. Because I had some, but then we melted it in the oven trying to dry the water out of it. So that's a thing that happens. So, welcome to the video. Today we'll be making a knife. The knife I've showed in other videos, and maybe it'll be completely done today. I mean, we'll cut it. We won't heat treat it because I don't have an oven, but my work does, so we will do that. And yeah, not sure where I was going with this. Let's see. Okay, so this knife, we are going to cut this knife out of this material. This is S7 tool steel. It is incredibly hard even in its annealed state, and then when you heat treat it, it becomes insane. Now the production ones are going to be made out of O1 because one, it's I don't want to say it's better suited for the knife we're going to be making, but I would guess it's going to be better suited for the knife we're going to make. It's also cheaper. S7 tool steel is really expensive because it's like the daddy of all like working steels, I guess. I don't know. That's just what Google says. So, but that's what I have on hand. I ordered O1, like I said, but I mean the metal place that I ordered it from, took a very long time to ship it. I mean, I ordered it on Sunday and they just shipped it. So here's the blank of tool steel we're going to be using. It's way oversized. It's ½ an inch. So we literally have to cut down ½ an inch of this material to ¼ inch is what the actual thickness is. Like large waste of material. So that's unfortunate, but that is what's going to happen today. So I got the actual knife design on top of the fixture plate that I have already built, and I'm gonna figure out the stock size. And so what I'm gonna do is I have these 1/4 bolts I'm gonna put on the end of the, drilled some holes and put on the end of the stock, and they're gonna thread into one of those holes on the fixture plate, and then we'll cut the knife out of the actual stock. So we obviously need enough room between the bolts and the thing that spins in the spindle, the cutter, and to be able to cut one of these out. And we'll probably end up cutting two because of the size of the stock. So what we're going to do is I'm going to go cut a piece of stock to somewhere close to 7 inches. It doesn't need to be precise, but we need to be able to measure it after. So we're going to go with 7 inches. Yep. 7 inches on the money. So we got 7-inch piece of stock, and then what looks like 3 1/8. So with that info, we're going to tell Fusion our stock size. Very close, but it doesn't need to be 100% accurate like mic'd and everything. Because, like I said, we're just going to drill holes into it. There's a wool over here. We're going to drill holes into it. And, what did I say, 3 1/8? Before I forget. And the holes are just going to line up to the plate that's on that fixture plate that I keep yammering about. So, okay, this is what I was talking about. So we have our stock, and I just placed the stock over our fixture plate, and then I projected the holes that lined up best with our stock, and it ends up being these 4 holes. Extrude to get our actual finished part, and here it is. This is the part. This is this part right here. We just saw cut. That's going to get faced just for appearance on the backside when we flip the part over, and then holes drilled to actually be able to bolt down to the fixture. So, okay, I got the tool path all set up. We're gonna face it. They're gonna do 1 inch with the cuts. So that's gonna be your step over is 1 inch for this. It's I'm not entirely sure what strength tool steel this is, what treatment of S7 this is. So in my calculator I just said it was the hardest, and that makes our facing operation 12 minutes long based on our feeds and speeds. So that's a long time, and I'm also not going to be running coolant except for the drilling. Apparently on tool steels you don't want to run coolant because blah blah blah. I don't really know, but that's supposedly, I don't know if it matters for a face mill. I know for end mills you shouldn't use coolant for tool steels because something to do with the heat doesn't leave in the chip, it actually stays with the cutter, and that dulls the cutter and blah blah blah. But let me take our 4-jaw out. I finally got the 4-jaw off. Alright, I'm going to indicate the vise in just to make sure. We got my tense indicator. Let's see that. Oh, good thing we checked. I don't know if you guys saw that, but it moved like 20 thou. That doesn't fit. Alright guys, it's within 2/10 indicated in now, and before it was off by like 25 thou. So if you're going to do something really important like make knives, you need to make sure your stuff's straight. Alright, good stuff. Now that that's nice and tight, let me post the program and get the probe out. Okay, here goes. We got our face mill. I'm gonna not run coolant. And yeah, what could possibly go wrong? Alright, that took forever. Next is to ram the center drill through it. It's raining! Okay, now that that's stopped making noise, things are looking fantastic so far. The surface finish feels better than it looks. I know it doesn't look that good, so, but I thought I would tell you guys that. So yeah, not teabag. So this will sit on that fixture plate that I'm about to show you, but I'm gonna file down these edges so she's nice and flat. So that's what it looks like. Plenty of 1/4-20 holes into her. Obviously you want to make sure there's nothing under it because you're relying on the flatness of that on top of the flatness of the thing you just made flat to be flat enough so that when you contour the part out, it's actually flat and level. It's a little tap. Nice little tap. Alright, then you take your part you just faced, put the pretty side on the bottom, because that'll become the bottom of our part. Take some of your bolts, 1/4-20s. So that's what it looks like. All bolted down to their little fixture. You can see they're not in line, but that's because we only followed the bolt pattern on here in Fusion. That makes it super easy and repeatable. This, all of it should be nice and straight. We trimmed the vise in. We know the height is perfect. Oh, I probably should have measured the height of the block. Alright, so I had to do some adjusting. Our part's back in there. Oh, hello. Hello. Our part's back in there on the parallels and off the fixture because the stock is too wide, too thick, because the cutter can't cut around the bolt heads because that's like a whole inch on top. So what I'm going to do is I'm going to channel out where the bolts are going to go. That way the bolts will sit much lower than the actual stock. Alright, I'm curious to actually see how the cutter looks after that. Alright, the tool's pretty warm. Kind of hard to tell. Still looks pretty sharp, which is good. These are the chips. I'm trying to see. So I think they're a little thin. You can see this straw color, these straw colored chips are kind of the heat being removed out of the cutter as opposed to, I mean that's a good thing, you obviously want the, but some of them look, I think they're supposed to be darker, but I'm not too sure. Alright, cool, so this one's 0.125 with the cut, that's 20% of the tool diameter, and same, the feed rate's a little bit lower, 5 inches a minute. Before it was like 6.7, and this makes the material removal rate much higher, so it actually cuts down on our cycle time from 5-something minutes to 4 minutes. So I'm curious to see how the actual chips look in comparison to that first adaptive we did on the left side. And then after this, it'll do a contour and just clean up the sides. Oh, I see some blue chips. So obviously probably more heat's being put into the chips than before, because it's a thicker cut. Ah, it's quality, guys. Oh yeah, definitely more blue chips in that pile. Alright, here's what we got. So, they're much more blue. Like a significant portion is blue than the other side. And there's the thickness. So obviously a little thicker than the other side. Tool's not that warm. That's not that long either. So that's cool. The smaller chips are from the contour. So I'm very curious to see how accurate my everything is, just for process, I guess. So this is supposed to be 135 in thickness from the bottom. So as long as I measured with the calipers correctly before, it should be close to 135. Yeah, that's not very close. I got 129. That's miles away from 135. 129 on the left side. Alright, well now I'm curious what the actual thickness of the part itself is. That's probably why, because the part is $4.99 basically. $4.99, and we said it was $5.04. Yeah, so that makes sense. So obviously we read it with the calipers wrong, because that's basically 4 to 5 thou away from our target. So what we need to do is tell Fusion what our actual part size is. Alright, that took a while, but let's see, we got the first tool path. It's going to take like an hour and 40 minutes, and then I'll probably cut this video at right after that, and then I'll continue working, but I'll post the first part, because part of my effort to get more videos out more often. Oh boy. Alright, and I'm going to walk away while it's doing the first tool path, so hopefully I come back to some good news, you know. But sometimes I'm just not that lucky. There's also a large possibility that we're going to hit the bolts, but don't be alarmed. I'll be back later. Alright, so looking good, looking good. That only took an hour and a half. One of these little islands left, but not a big deal. So the next tool is tool 17. Oh man, I look tired. Alright, last tool path for this first stop. It's 4 hours long. It's actually the next day. And this is going to conclude video 1. So I'm going to start this. I'm going to go edit the sections that I've done, and then I'll record part 2 for the rest of the week, and then I'll compile that up and blah blah blah. And part 2 is going to have like the soft jaws. We're going to make the soft jaws, and then basically like the second side of the knife, of course. Alright, so let's start this, and then I'm gonna leave because it's a 5 hour long tool path. Oh yeah, I forgot something. Ah, yes. Residential power. Amazing.